Hello, everybody. This is Bharat, Assistant Professor, Department of Electrical and Electronics Engineering, SNS College of Technology, Coimbatore. We have been seeing the lecture series of the course Measurement and Instrumentation. This is a course for fourth semester second year EEE students. We have been discussing great topics from this subject from Unit 1 and Unit 2. In Unit 2, in the previous videos, we just discussed about the topic of DC potentiometers and DC bridges. So today's topic is going to be about the next type of a bridge, which is another classification of the bridge, which is called as the AC bridges. Under AC bridge, we have several classifications. One is going to be the what we are going to discuss in today's class. That is going to be Maxwell's bridge. Come, let's get into the video. Today, we are going to start with the Unit 2 comparative methods of measurement, where we are going to see the topic AC bridges and the Maxwell's bridge. Bridges. As we all know, we have a small recap of what is this bridge is all about. In order to discuss about in detail, the bridges are a measurement system. We just saw about the basic principles of bridges and measurement of resistance of bridges, low, medium, high resistances, using different methods, using DC potentiometers, using Wheatstone's bridge, using Kelvin's bridge, Kelvin's double bridge, etc. And today we are going to discuss about the next topic of AC bridges, how the AC bridges are going to be used for the measurement of impedances in a system where electrical system works. Starting with the DT chapter of empathy, we'll just discuss out why we need to go for Maxwell's bridge. Maxwell's bridge is very important to understand the concept of AC bridges. The use of Maxwell's bridge is to find out the inductance measurement for the power system networks and power electronics concepts, transformers and motors, quality control, renewable energy systems in power systems, precise inductor designs for motors, generators, and any energy storage devices. Career opportunities in Macy systems are all higher when you just use this Maxwell's bridge. Because of these advantages, we need to study about the Maxwell's bridge. So this diagram shows the simplest circuit of what is a Maxwell's bridge. What does the Maxwell's bridge consist of? The Maxwell's bridge consists of construction is much more similar to that of the previous bridges we discussed. We have the four limbs. At the center, we have a deflector or a galvanometer. It's supplied by an voltage source. On both the sides of the limbs, we have few resistances and inductances connected. The points A, B, C, and D are the junction points of this Maxwell's inductance bridge. You could see the diagram where we have one arrow mark which represents a variable resistance and variable inductance. R1, L1, and across the voltage is E1, R3 across the voltage is E3, R2, L2 across the voltage is E2, and R2, I2 across the voltage is E4. You could see the phase diagram representing the Maxwell's bridge. So what is the working principle of a Maxwell's bridge? So we need to have one unknown inductance, Lx, can be calculated in terms of unknown capacitance and C1 when the bridge is in a balanced condition. So the balanced condition of the bridge is already discussed. So we have the balanced condition since we have the four different cases. We have resistance and inductance connected to the four different limbs. So we are considering the balance condition as Z1, Z4 is equal to Z2, Z3. So where Z1 is parallel that of R1 and C1, and Y1, that is the admittance, is the opposite of the impedance, which is 1 by R1 plus j omega C1. So Z1 is given with an expression R1 parallel to 1 by j omega C1. So Y1 is the opposite of the impedance, as I already told you. So we are going to calculate, based on these formulas, we get some expressions to calculate the unknown value of impedance. After calculating the unknown value of impedance, this is the use of a Maxwell's bridge. So what are the various applications of using a Maxwell's bridge? You could see Maxwell's bridge is variously used for inductance measurement, measuring inductance of the coils and chokes, coil testing, testing of transformers and motor windings, laboratory usage, precise measurement in calibration labs, etc. What is the practical setup? You could see the practical setup, what we just discussed this in the laboratory. So you have a bridge panel, Maxwell's bridge circuit is attached, source voltage is AC, and the detector, you can use this any type of a detector as an oscilloscope, a galvanometer, or any other detectors to check whether there is a current flow through the balanced circuit. Okay, as a whole, we have just discussed about what are the AC bridges. What is the one classification of AC bridges? The Maxwell's bridge. So Maxwell's bridge used to find out the value of the impedance or the unknown value of impedance. Thank you. So we'll meet in the next class with another type of a bridge circuit used for measurement. Thank you.